Net zero. Everyone is talking about net zero everywhere all at once. But net zero what? What does this even mean? Is it a reasonable goal? How far along are we on the way? And do we have any chance of reaching it? That's what we'll talk about today. First things first, what do we mean by net zero? Until recently, the term had no official definition, but in 2022, the International Standards Organization blessed the word with this clarification. Net zero is the condition in which human-caused residual greenhouse gas emissions are balanced by human-led removals over a specified period and within specified boundaries. Oh God, so many words. Okay, let's look at this in detail. Residual means what's left after we try to reduce emissions by other means. The word balanced says that we remove as much as we emit. This is why it's called net zero. Next, net zero is not just about carbon dioxide emissions, but concerns all greenhouse gases, notably that includes methane. Then there's the phrase over a specified period, which refers to an average over time. That's because greenhouse gas concentrations rise and fall throughout the year due to natural causes, such as trees taking up carbon dioxide. And finally, specified boundaries means that you can use the term net zero to refer to a region. Typically, that'll be a country. By the way, this video comes with a quiz on quizwithit.com. Even better, if you subscribe to Quiz With It, you can collect points from all our videos and you get free access to the transcripts with links to all references. It's an easy way to support both our channel and, hopefully, your memory. So go check it out. Okay, net zero means that we're removing as much as we're adding. But why has this become a goal? You might think it's because that'll prevent further global warming, but actually this isn't so. First, net zero means that we don't pump greenhouse gases into the atmosphere, but their levels can increase for other reasons, for example, wildfires or volcano eruptions or methane leaking from the ground or from other places because you've been eating too many beans and so on. The second important thing to know about net zero is that Earth will continue to warm even if greenhouse gas levels stabilize. At the moment, our planet retains more energy than it sends back out into space, and that leads to warming. It'll continue to warm until it again sends out as much energy as it takes in. But warming something as big as an entire planet takes a long time. Especially the oceans take up a lot of heat. So the temperature increase lags behind the increase in carbon dioxide levels. This means that Earth will continue to warm for quite some time, even if carbon dioxide levels stabilize. The third thing to know about net zero is that it doesn't make sense in and of itself, because on its own it tells you nothing about the expected temperature increase. Relevant for that is the carbon dioxide level at the time we reach net zero. That is, if we reach net zero with 600 parts per million carbon dioxide in the atmosphere, that'd be very different from reaching it at 800. Yet in both cases we might say, hey, it's net zero. Net zero only makes sense in combination together with a total emissions target. Basically, you need a requirement for the integral over the annual emissions, as well as a requirement for the time by which the integral stops growing or the new annual contribution reaches, well, net zero. Another thing that net zero doesn't take into account is changes in aerosol levels. Aerosols are particles which are so small they remain airborne for a long time, like those in dust and smoke. Some of them reflect sunlight and reduce global warming. Their levels go up, for example, when we have a big volcano eruption, or go down when coal mines are closed. Aerosols affect global temperatures, but net zero doesn't say anything about them. That was a long list of ifs and thens. Why are we even talking about net zero? Because it's an easily quantifiable intermediate goal. And when it comes to policy making, quantifiable goals are super important, because otherwise you can't pin down anyone on what they're supposed to do. Okay, so where are we on the way to net zero? In brief, not very far. Under the Paris Agreement, countries agreed to limit global warming to well below 2 degrees Celsius above pre-industrial times and make efforts to limit it to 1.5 degrees. We are currently at 1.1 degrees. By the way, this is the global average. It's only 0.9 over the sea, but 1.6 over land. And Europe is warming faster than the global average. It has already reached 2.3 degrees. At the moment, we emit globally about 55 billion tons of carbon dioxide per year, and as you see, it just keeps going up. Of all greenhouse gases, carbon dioxide makes up about 3/4. The rest is mostly methane and nitrous oxide. According to current estimates, meeting the 1.5 Celsius goal with 50% probability means we have a total of roughly 400 to 800 billion tons of carbon dioxide left that we can emit. So that's the integral under the curve. For every trillion tons that we overshoot, global surface temperatures will rise by approximately 0.45 degrees Celsius. You might have noticed that these emission curves don't look like we're on the track to net zero. It looks more like net infinity. To limit temperature rise to 1.5 degrees, we'd need emissions to peak before 2030 and fall to net zero by around 2050. At the moment, it looks, however, like we'll exhaust the 1.5 degrees budget by 2030. According to projections from the Intergovernmental Panel on Climate Change, temperatures will continue to increase until 2040 and go beyond the 1.5 degrees limit in all realistic scenarios. Okay, that was depressing, but it's not as bad as it sounds. That's because the increase in carbon dioxide emissions in the past years comes mostly from China, and we better be ready for India, which is likely to catch up with China soon. These two countries combined have a huge impact because they account for over a third of the world's population. But take a look at Europe. You see that emissions have gone down significantly after peaking around 1979 and are now as low as they were around 1965. Meanwhile, the economy has been doing mostly okay. Between 1990 and 2018, the EU has reduced greenhouse gas emissions by 23%, while the economy grew by 61%. No, I don't want to talk about the German economy. In the US, emissions are decreasing as well, though they lag a bit behind Europe. US emissions peaked in 2007 and are now as low as they were around 1988. Even in China, the carbon intensity of the economy is decreasing, and the Chinese government says they want to reach net zero by 2060. So we've seen it's possible to decarbonize even large economies without sacrificing prosperity. Still, the challenge is enormous and we're not doing remotely enough. A UN report from 2022 concluded that current policies are woefully insufficient to meet the temperature goal of the Paris Agreement. They're not the only ones who have reached this conclusion. The German environmental organization Germanwatch annually gives out a climate change performance index. It takes into account greenhouse gas emissions, the use of renewable energy accounts, and climate policies. The 2023 ranking has Denmark on top, followed by Sweden and Chile. The UK is in 11th position, the European Union 19th. Japan, China and the US are around 50. At the bottom are Saudi Arabia and Iran. The authors of the report explain that the EU receives such a good ranking not because they're great in terms of doing things, but because they're great in writing policies for doing things. And that's although the EU policies, if they became reality, would not be enough to meet the terms of the Paris Agreement. So the situation is that we're not doing remotely enough to curb emissions, and the only thing we can do to get to net zero is to actively remove carbon dioxide from the atmosphere. The International Energy Agency concluded in a report last year that at this point, reaching net zero by 2050 is virtually impossible without carbon dioxide removal. The IPCC too writes that carbon dioxide removal is required to limit warming to 1.5 degrees, and that carbon dioxide removal is part of all modeled scenarios that limit global warming to 2 degrees or lower by 2100. At this point, all realistic future scenarios, including those of the European Green Deal, rely on carbon dioxide removal. So yes, carbon dioxide removal. We need to talk about that. Carbon dioxide removal means a net negative emission. You take carbon dioxide out of the atmosphere. Carbon dioxide removal should not be confused with Kermit the Frog. They're two completely different things. Just checking if you're listening. Carbon dioxide removal should not be confused with carbon capture and storage, CCS for short, which is not necessarily even a method of carbon dioxide removal. CCS is what you do at a power plant that produces carbon dioxide. You filter out the carbon dioxide, bind it in some kind of solid and bury it, capture and store. But if you dig up fossil fuels and burn them, then capturing the carbon dioxide before it goes into the atmosphere can at the very best lead to net zero emissions. In practice, it's still a small positive emission. So carbon capture and storage at fossil fuel plants is not a method of carbon removal. It's just a method to reduce carbon emissions. And it's not Kermit the Frog either. But CCS will remove net carbon if you do it with biomass, like you grow trees or other plants which collect carbon basically. Then you burn them, but rather than just giving the carbon back into the air, you catch and bury it. This will actually reduce the amount of carbon dioxide in the air, so it's carbon removal. It's called BECCS, bioenergy with carbon capture and storage. There are also other ways to remove carbon dioxide, like you can pump air through giant filters and extract the carbon dioxide. This is known as direct air capture. Since water takes up carbon dioxide from the air, you can try to extract it from the water instead. You can also cover large areas of land with minerals that capture carbon. This is known as rock weathering. Or you can burn biomass with a special method and catch the carbon in stuff called biochar. I talked about the different methods in a previous episode. At present, we remove a bit more than 2 billion tons of carbon dioxide a year from the atmosphere, but that's almost all by vegetation. It's somewhat of a stretch to say that we remove it. It's really trees. Then again, for all I know, you might be a tree. If that's the case, please say hi in the comments. Unfortunately, it's difficult to significantly increase the amount of vegetation on the planet. The part that we can improve, the one that comes from new technologies of carbon removal, is at present 2.3 million tons a year. That's about 0.1% of the total. Nearly all of the 2.3 million tons are either bioenergy with carbon capture and storage or biochar. How much carbon do we need to remove? According to a recent report by an international group of scientists, to stay below 2 degrees of warming, we'll need to remove almost an additional billion ton each year by 2030. By 2050, that'll need to be almost 5 billion tons each year. So those 2.3 million need to go to about a billion in 7 years. Yeah, I can't see that happening either. Neither can people who study these things for a living. In 2023, the first global assessment of carbon dioxide removal appeared. The report estimates that if we include all new technologies of carbon removal that are currently being developed, we could get to roughly 12 million tons per year by 2025. They extrapolate optimistically to 2030 and say that by that time, we could see about 40 million tons. Just as a reminder, we'll need to reach 5 billion with a B, like bonkers. The report also very nicely says that announced carbon dioxide removal targets from industry groups and companies imply faster growth than has been seen historically for most technologies. Zing! Why are we not making more headway on this? I think it's a two-part problem. One is that a lot of people are confusing carbon dioxide removal with carbon capture and storage. But carbon capture and storage at fossil fuel plants doesn't even count as carbon removal. On the other hand, carbon capture and storage with biomass does. These are two different issues entirely. And by the way, neither of them is Kermit the Frog. This confusion then ties into the next problem, which is that some environmental groups are lobbying against carbon capture and storage at fossil fuel plants, and then they're throwing out the baby, that's the carbon removal, with the bathwater, that's fossil fuels with CCS. Greenpeace, in true form, basically claims that CCS is a scam by the fossil fuel industry, which is secretly planning to use this captured carbon dioxide for enhanced oil recovery. But even the European Environmental Bureau has expressed concerns about carbon capture and storage, saying they believe that this technology would not encourage the switch away from combustion-based processes. Someone should tell them that the problem is not the combustion, it's the release of carbon dioxide during the combustion. In summary, there's no way we'll reach net zero by 2050 without rapidly building capacity for active carbon dioxide removal. Thanks for listening. We'll be back next week.